Hello everyone and welcome to the Clinical Cousins YouTube channel. Today we are going to go over equilibrium potentials. Do you remember that electrochemical gradient? It is a substance's motivation to get inside our cell. The rest of the story is that if an electrolyte like sodium were able to freely travel into our cell as much as it wanted, it would eventually stop coming into our cell. Why is this the case? Because our electrolyte is caught in a state of tug of war between an electrical pull and a chemical pull. At first, when all of the electrolyte is outside of the cell, we say that there's a lot of chemical gradient. We imagine that our sodium is like a bachelor and there are a lot of pretty ladies within the cell. Our sodium bachelor does not want a lot of competition. Therefore, we say that there is a high chemical gradient present. Now, on the other hand, we have our negatively charged cell. Because opposites attract, our negatively charged cell will attract our positive electrolyte, sodium. At this point, there is a high electrical pull into the cell, and there is a high chemical pull into the cell. Now, as soon as we open up a path, a sodium channel to the inside of our cell, sodium would enter one at a time until our sodium had no motivation to move. This happens when our electrical pull and chemical pull are finally equal and opposite. Now, our cell started out at negative 70 millivolts, and as our sodium came in, it got more and more positive. It gets so positive, in fact, that at around 65 millivolts, our sodium became happy and it stopped coming into the cell. This is the equilibrium potential. The potential in millivoltage in which our sodium stopped diffusion into the cell and was at equilibrium. In other words, this is the millivoltage that sodium wants the inside of the cell to be. This is because when the millivoltage reaches about positive 65, our sodium can finally rest. Until the cell millivoltage is about positive 65, our sodium will not rest, and it will constantly be moving inside and outside of the cell until it reaches this millivoltage. Keep in mind that each electrolyte has their own happy millivoltage that it would like the cell to be. We will learn very soon how all of these electrolytes will compete to make the cell closer to their own equilibrium potentials. As always, thank you for taking the time to learn with us today, and remember to like and subscribe for more content.